the day. This is the fourth session on time response analysis. In this session, we will concentrate on time domain specifications. This is the waveform of a second order system. So here the zeta value, based on the zeta value, this oscillatory part vanishes. So as the zeta increases, this oscillatory part decreases early, and as the zeta increases, there won't be any oscillatory part, there will be only exponential part, and it reaches the steady state value 1. The steady state value is 1 because it is for unit step input. So output is 1 unit step. So in this we can generalize this as a single waveform. In this, based on the zeta value, this value oscillatory waveform may increase by magnitude or decrease by magnitude, or this oscillatory part vanishes and there will be only exponential part. Now here in this session we will concentrate on the time domain specifications. Time domain specifications which are important for the designer to design a controller. So what are those time domain specifications? The first one is TD, that is delay time. So from the graph we can say it as it is the time taken to reach 50% of the steady state value, right? So delay time TD is the time taken by the response to reach the 50% of the steady state value. So next is the TR, that is rise time. So from the graph, it is the time taken by the response to reach final value, but here the final value reaches many times. So here also it is reaching the final value, final value, and so on. But TR is the time taken by the response to reach the steady state value at first instance. So next is the TP, that is the peak time. So here it is in this response, the maximum response reached at this time, the corresponding time is called as a TP. So TP or a peak time, it is the time taken by the response to reach the maximum value. So next is this MP, that is maximum overshoot. So if we concentrate on this, it is the difference between a peak value and steady state value or a final value. So it is the ratio of maximum overshoot by steady state value, final value. So here C of Tp minus 1 divided by 1. So it is C of Tp minus 1. Okay. Then last one is a settling time, TS. So here after this time it will be within allowable error, desired error. This error may be 2% or 5%. So TS can be defined as it is the time taken to reach and stay within a desired error. So it will reaching the less than 2% error, and also it is staying within 2% error. So settling time is the time taken by the response to reach and stay within a desired error. So as I defined, delay time, it is the time taken by the response to reach 50% of the final value for very first instant. Rise time, it is the time taken by the response to rise from 0 to 100% of the final value for first instance in case of under-damped system, and 10 to 90% of the final value for first instance in case of overdamped and critically damped system. Peak time, it is the time taken by the response to reach maximum value for very first time. Maximum overshoot, it is the ratio of maximum overshoot to the final value. Maximum overshoot is the difference between maximum value and final value. That is, MP can be given by the formula C of Tp minus C of infinity by C of infinity. And a settling time, it is the time to reach and stay within a specified error. Normally the specified error is either 5% or 2%. In the remaining slides, we will concentrate on deriving these terminologies. First, we will concentrate on our rise time. Now, unit step response of a second order system for 100 amp case is C of t is equal to 1 minus e to the power minus zeta omega nt divided by root of 1 minus zeta square into sine omega dt plus theta. Now at t is equal to tr, what happens? C of t is equal to C of tr equal to 1. That is a final value. This is 1 is because it is the unit step response. For unit step response means input is the unit step. For that means u of t is equal to 1 for t greater than or equal to 0. So based on that, this is 1. Now C of tr, if I substitute t is equal to tr and it is equal to 1, that means 1 minus e to the power minus zeta omega n tr divided by root of 1 minus zeta square sine omega dt tr plus theta equal to 1. So if I rearrange, this 1 and this 1 gets cancelled and becomes 0. So minus sign, it is of no use. So e to the power minus zeta omega n tr divided by root of 1 minus zeta square sine omega dtr plus theta equal to 0. So in this is the exponential term. This cannot be 0. This is 0 only when this tr is infinity. That means it is a steady state. So steady state, it is 0 means it is of no use. So it cannot be 0 exponential term. So sine omega dtr plus theta equal to 0. So this term, sine term is 0 only when this is a multiple of pi. So it is possible only when omega dtr plus theta equal to pi, 2 pi, 3 pi and so on. Because sin pi, sin 2 pi all are zeros. So and according to the rise time definition, it is the time taken by the response to reach 100% of the final value at first instant. So in this case, this becomes 0 at very first, that is this is equal to pi. So I will consider only the pi value. So this omega dt plus theta equal to pi. So rise time tr is equal to pi minus theta by omega d, where theta equal to tan inverse of root of 1 minus zeta square by zeta. So this is the expression for rise time. Next, peak time. What is the peak time? It is the time taken by the response to reach maximum value. So now we will consider the unit step response of a second order system for 100 amp cases, the same as this. So to find the expression for Tp, differentiate C of t with respect to t and equate to 0, because according to the mathematics, any function y is maximum at any value x. This value can be calculated by differentiating it. dy by dx equal to 0. Similarly, dct of dt equal to 0. So what is the differentiation of this? This is the 0, differentiation of 1 is 0. Differentiation of this is a product, both are containing a t. So product rule I need to apply. So u to the power minus zeta omega nt by root of 1 minus zeta square Sin omega dt plus theta becomes cos omega dt plus theta into omega d minus, so minus sign adding this e to the power minus zeta omega nt by root of 1 minus zeta square. Differentiating this will remains this and minus zeta omega sin omega dt 0. So both are equal to 0. So by rearranging, this becomes this, because minus can be taken outside because it is equal to 0. So this inside term is only 0. So omega, this exponential term cannot be 0, so can be taken outside. So omega d cos omega dt plus theta zeta omega n sin omega dt plus theta equal to 0. So by rearranging, this is equal to this. So sin by cos, cross multiplying, tan omega dt plus theta equal to omega d by zeta omega n. So what is omega d is equal to omega n into root of 1 minus zeta square. So omega n gets cancelled. So root of 1 minus zeta square by zeta, which is equal to tan theta. So it may be a tan theta or tan pi plus theta. Why tan pi plus theta? Tan of in a third quadrant it is positive only. So tan pi plus theta we will consider. So based on that, omega dt plus theta equal to tan pi plus theta. So omega dt plus theta equal to pi plus theta. So the peak time dp is equal to pi by omega d, theta is cancelled. So this is the expression for a peak time. Now we will concentrate on maximum overshoot. So according to the formula, percentage maximum overshoot, percentage MP is equal to C of dp minus C of infinity divided by C of infinity into 100. Now unit step response of a second order system for 100 amp case is C of t is this. Now we will find this C of t at t is equal to dp and t is equal to infinity. When t is equal to infinity, C of t infinity, t is equal to C of infinity equal to 1 minus e to the power minus zeta omega into infinity and this. So this becomes 0 because e to the power minus infinity is 0. So it is 1. So at t is equal to dp, what happens? C of dp is equal to 1 minus e to the power minus zeta omega and dp root of 1 minus zeta square omega dt sin omega dt dp plus theta. So if I substituting dp is equal to pi by omega d as we have derived in the previous slide. So if I substitute dp is equal to pi by omega d, what happens? C of dp is equal to 1 minus e to the power minus zeta omega n pi by omega d and this so on. So here what will happen? So C of dp is equal to 1 minus sin e to the power minus this one. So this pi by omega d gets cancelled. So it becomes sin theta. Right? Now what is sin theta is equal to root of 1 minus zeta square. Based on the tan theta is equal to root of 1 minus zeta square divided by zeta. So sin theta is equal to root of 1 minus zeta square. So these two gets cancelled and remains 1 plus e to the power minus zeta omega n pi by zeta. So if I substitute omega d is equal to omega n root of zeta square, it becomes 1 plus e to the power minus pi zeta by root of 1 minus zeta square. This is by substituting omega d. So C of dp is this, C of infinity is 1. So if I substitute these two in this expression, so percentage overshoot becomes this minus 1. So 1 and 1 gets cancelled. So e to the power minus pi zeta divided by root of 1 minus zeta square into 100. So this is the expression for maximum overshoot. So next is the settling time. So we will consider the same unit step response of a second order system. For 100 amp cases, C of t is equal to 1 minus e to the power minus sin zeta omega nt root of 1 minus zeta square sine of omega dt plus theta. So in this term is a decaying component which reduces the sinusoidal oscillation. So as we might have seen in the waveform, that sinusoidal oscillation decays after some time. So this is the component which decays this part, sinusoidal component. So settling time is decided by the exponential component. So let us consider the specified error be 2% to derive the expression for settling time. So 2% error, that means C of t value is 2% less than the final. That means 1 minus 0.02, that is 0.98. So this is the oscillator part which vanishes. So 1 minus e to the power minus zeta omega nt divided by root of 1 minus zeta square equal to 0.98. So if I take to the other side, e to the power minus zeta omega nt divided by root of 1 minus zeta square equal to 0.02. So taking the natural logarithmic on the both the side. So here this is log of nearly 1 minus zeta is small, so it is log of 1 is 0. So e to the power minus zeta omega, natural log of this is minus zeta omega nt equal to natural log of 0.02 is minus 4. So the settling time Ts is 4 by zeta omega n. Settling time is 4 by zeta omega n for 2% specified error. Similarly, if we derive for 5% error, settling time is Ts is equal to 3 by zeta omega n. So in this session, we concentrated on time domain specifications and expression for those time domain specifications.